is the first class, so unlike the NPTEL course where we strictly had to finish in 40 hours, I want you to relax. I want to spend a few minutes asking you a very simple question. Why are you sitting here? It's a deep question, but you can give a shallow answer. No problem. A couple of answers from you. Why are you sitting here? Why are we here? To get a degree. Good. That's the honest, straightforward answer. Every class, I will spend a few minutes chatting with you. I didn't try it today, but from next class, we will observe silence for a couple of minutes. For many reasons. The first reason is, it's a transition. You come, your heartbeat is high, you're a little agitated. It's actually very difficult for a student to keep switching subjects and teacher. So relax. It's a transition. In the Tibetan world, they use a word called bardo. It's a transition. And bardo can be transition at many levels, even from death to life. Okay, life to death. Right, so relax. The other thing is, it's very difficult to actually be quiet. You can be physically quiet, but the mind is. So try to relax at that level. I'll show you a few tricks how to settle down. And be totally relaxed in peace. Drop all your tensions. Then be in a state where you are comfortable and ready to absorb, to learn. There is a joy in learning. The happiness comes from learning. And the learning we are normally used to is not necessarily the kind that gives us real joy. We'll soon find out how little you know about this subject. This is a subject being taught at a postgraduate level. But over the many past years, we've found that unless the fundamentals are strong, it's difficult to put up a superstructure on that. So much of what we are going to learn here will be a revision of what you should have learned at BTech level. And we'll try to go deeper on the same topics. Is that clear? Advanced Design of Concrete Structures or Advanced Theory and Design of Concrete Structures, the title will be clarified. It's an A slot. And today I'm going to start the first module, but let's look at all the modules. So let's look at the course outline. It's a review of basic concepts, background to code formulations. So primarily it's the Indian code, IS 456 for reinforced concrete and IS 1343 for pre-stressed concrete. We have a separate pre-stressed concrete course. But we didn't want any student leaving IIT without knowing a little bit of pre-stressed concrete. So that's an elective course. Some of you may not take it. But this is a compulsory course. It's a core course. So we raised 3 credits to 4 credits to accommodate pre-stressed concrete and some other advanced topics, right? So we'll cover the basics, and you need to know that well. And the pre-stressed concrete course will be an advanced version of that course. First, introduction, basic properties, durability, design philosophy. Given 8 hours, but it could be plus or minus. Second, basic behavior and design of reinforced concrete flexural members. Members in bending, okay? Beams, slabs. Behavior of pre-stressed concrete flexural members. So we'll cover the simple topics first. So bending is the fundamental topic. And then we'll go to columns. When we say flexural members, we are covering both bending and shear. Okay? Because we're covering basically all that happens inside a beam. Then we bring in axial force, axial compression, could be axial tension also. So that's all behavior. behavior at the section level. That's what you know the difference between section analysis and member analysis. What's the difference? Difference between section analysis and member analysis. Okay, let's start with simple basics. This is all about structure, right? What is a structure?
Something which can support a load.
One at a time. You raise your hand then, Alice.
Something which can support a load.
Wait a minute. Now let's go slow. Supposing your grandmother asks you, look, you came to IIT and all that. What are you learning? You say you are in structural engineering. Structure, I've heard that word before. Tell me what is it? And you should give an answer which is generic. She has her husband used to be a great philosopher. She's seen a book in the library shelf which shows Structure of Indian Thought by P.T. Raju. I have that book at home. That doesn't take any load as far as she knows. Then you have computer science courses here where they teach data structures. Now you're getting it. So structure, the beautiful word structure, what does it mean? It has this meaning too, but let's begin with the most generic meaning. What is a structure? Now I want to hear some answers which are so generic, and then we'll come to the particular. What is a structure?
It's a member which is able to take load and transfer the load.
Structure of Indian thought, data structures, they can't do any of these things.
Particular form.
So, see, some people are good at structured thinking and bad at unstructured thinking. Now the question I'm asking you are unstructured because you never thought you will be asked such questions. Right? Our classes are going to be partly structured, mostly unstructured. It's free format. Artists believe only in the unstructured way. Poets only, so we engineers always are in the box. We are too structured. So I want to loosen up you guys. We are too much left brain oriented. Left brain is always analytical. It wants to break things down. That's structured. The right brain has holistic thinking. It leaps from here to there and gets a big picture.
From one point to reach another point through certain
That's
classification.
too generic. This has a specific meaning. Anybody? Okay. If you look at the dictionary, I did look up because I've written some books called Structural Analysis, Advanced Structural Analysis, so I want to read. It simply says the framework. Beautiful. A structure is a framework that is an assemblage of many components kept in an ordered manner. It's a framework. It could be actual physical object, a physical framework like a frame building or a truss, that's a framework. Or it could be a conceptual framework. Data structure is a conceptual framework. It doesn't take any loads. Structured thinking is conceptual. The other thing is solid. You're a material reality. But you're also right. Let's say your uncle is building a house and you ask him what's the stage of construction. He said the structure is ready. So a building also has structural components and non-structural components. Right? What's the difference? The typical house. Can you tell me what is structural and what is non-structural? Sorry, we are going off the topic, but I want you to master everything. So what is structure? What is outside the structure? All of you should speak and not the same person. What's the difference between the structure and the non-structural elements in a typical building. So actually, you gave the answers. Maybe you. What's your name? You came late. Don't come late.
Sorry, sir. I'm Harikeshwar Kumar
From
from MES department.
MES. Okay, good. Tell me what's
The structural member is the member where if we put the load, it transfer the load.
okay.
Suppose it is a portal plane.
Okay, very good. So he's saying that's where all your answers converge. To qualify to be called a structural component, it should be load resisting. Simple. If you remove it, you could get a collapse. No, it's a skeleton. In Mumbai, some years ago, some people in the ground floor, because they wanted some space, they knocked off a column. They thought it's just some element. They knocked off the column and the building caved in. So you can't do that. That's a problem unless you have enough redundancy in the system. And in structural engineering, if you're a good structural engineer, you should know you'll have clients who will knock down things. So you should either write there, don't knock this down, or you should ensure that even if you knock it down, you get a local collapse and not a global collapse. Okay? So there are good. So what is non-structural is that which you could remove and they're add-ons. So what are these add-ons in a building typically? Huh? Partition walls. Yes. In a framed structure, the columns and beams form the framework, and even the external walls can be removed. Partition walls and doors, windows. Very good. You think only vertical elements are not structures? Flooring, tiles, right? So there are a whole lot of things. Cladding. It's good. So that's a structure. Now we are talking about concrete structure. What does the word concrete mean? We'll come to that. Okay, let me finish. So you have serviceability limit states, you have limit state, limit analysis. What is limit analysis? What is serviceability limit state? What is a limit state? By the way, both Romania and France follow the Eurocode.
We follow in the last 3 years. We just start following, sir.
It's okay. Today you follow, right?
Yes.
Okay. And you've not done what Britain did. Still there in the European Union. Okay, so you'll find that there's a lot. It's all codes are only. All nations are concepts. Remember that. There was a lady called Sunita Williams. You've heard of her? Who's she? She's an astronaut. US Indian American. I'm told that when she visited India, she was in a class with school children. One girl asked, "How did India look from outer space?" She said, "To be honest with you, I couldn't make out. I could see only blue water and land. But I saw that all land was one." Then she added something beautiful. All divisions in the land, concepts of country and nations, they're actually not there. They create divisions, and you'll find that all problems, all loss of happiness in human beings emerge from conflicts, especially at the boundaries between these nations. Very important concept. Why did I talk about all this? Yeah, Eurocode. So, luckily, the Indian code and the European code, we follow the same system, same limit state concepts, the same partial safety factors, so you won't have any problems. We'll also cover what the American practice is, where they have the resistance and load factor design. Okay, tell me, what is a limit state? So You should know. You studied. All of you in your undergrads, you studied.
State of impending failure.
Wonderful. Correct. State of impending failure. What is the meaning of impending failure?
It's just about to fail.
Just about to fail. It's just about to fail. It's on the boundary line of failure. One side you have failure, the other side you. What is failure?
Losing its power.
General. Now we'll again go back to like structure. What is failure?
Unstability of a structure.
Arey yaar, leave aside the structure. What is failure?
Anything which doesn't qualify. Something loses its function.
Something which doesn't
Qualify.
Good. That's a nice way of saying it. What did you say?
Lost its function.
Lost its function. Let's say you fail. You fail not in this subject. Not in this subject. Some other subject you're not interested in, you didn't study. In the exam you failed. 40 is the pass mark, you got 38. So you lost your function. His thing is correct. You didn't meet some qualification level. Right? You didn't lose your function. Or did you lose your function? Your body got paralyzed. Do you understand what failure means? Failure really means, it could mean losing a function. But it fails to qualify some requirement, some standard. Many of these standards are conceptual. Nothing is going to collapse if you fail. Can you give an example in structural engineering where no serious damage is likely to occur even though you have transgressed into the failure zone? Yielding you is bad, it's visible. You do damage. Say there's a deflection limit spanned by 250 or 350. You calculated, it says 20 mm. Your calculation shows you got 30 mm. Will the function stop? You can't use the building anymore? Of course you can. First of all, who laid out this 20 mm? Secondly, your calculated value, is it correct? There's so much of uncertainty, so much variability. So nothing, the sky is not going to fall down if you transgress some limits. Similarly, a good teacher, a good recruiter knows that there's very little to differentiate between the fellow who got 38 out of 100 and 42 out of 100. Both are the same. On a rainy day, the guy who got 38 could have got 60. The guy who got 42 would have got 20. We all know that. But society lays so much importance. He failed. You failed to say term correctly. Nothing is going to happen. So welcome failure. Why is failure important in life?
To get success. Learn from this. Learn from those people.
Yeah, because if you don't fail, in fact, most advances in structural engineering have happened only out of failures. Because the thinking mindset. So we always want to stretch our limits. Why did it fail? What can we do to prevent future failures? That's why, what can we do to pronounce term correctly? But again, master it. Exactly. So failure is not a bad word. Don't get scared. It's a good word. You should treat it properly. Okay. But of course, you could get a collapse also. Now, the codes are very clever. So you will find that they are conservative. They say don't cross this line, but they always leave some margin because they know that accidentally you may cross the line. So it's not that it's going to suddenly collapse, but there is some line where it will collapse. We'll learn about all that soon. Also, but this limit analysis, what is limit analysis and why is it difficult? Give some examples. What is the difference between analysis and design in this subject? What's the difference? We use these words, no? Structural analysis, structural design. What's the difference?
Calculating reactions.
What is structural analysis? Calculating reactions? Calculating reactions is, what is reaction? Calculating reactions is part of structural analysis. What's the big picture? What is structural analysis? What is analysis? Any analysis?
Understand the behavior of test itself.
To understand what is behavior? When you apply some load,
How it is responding.
how it is responding. Very good. So you use correct word. You have a load, you have a response. I ask you a question, it's a load. You give an answer or don't give an answer, it's a response. That which responds is called a system. It could be a structural system, it could be an economic system, it could be a political system, it could be a physiological system, it could be a psychological system. System is very complex. So we try to break it down into subsystem, put some order into it, make it into a framework which you can. The advantage of having a framework is you can put things in place and you can make predictions. Because there's a pattern in the behavior. And in science, we believe there are certain laws which govern the system behavior. And the whole endeavor of science is to find out what will be the response if you give the system a certain stimulus. Sometimes we do reverse engineering. Doctors have to do that. You go to the doctor with a sickness and he asks you a question, what are the symptoms you have? And he says, this could have been caused by typhoid. So all science is about discovering the relationship between the load of the stimulus and the response. And that is called behavior. Okay? That is called. So we are talking about structure. Very well said. Okay. Now, what is limit analysis? Structural analysis is the estimation of the response of a given structure subject to given loading to determine its response. The response has two components typically. One is related to loads, stresses, that we call the force response, bending moments. Those are internal forces, bending moments, shear forces, twisting moments, axial forces. The other is a displacement response, deflections, slopes, angles of twist, strains. So we want to find the relationship of this to that. And design is all about proportioning a structure, putting the reinforcement in such a way, detailing in such a way that it responds the way you want it to respond. So typically there are some requirements of a structure for qualifying, for serving its intended function. What are those requirements of a good structure? So this is a well-designed structure. How do you make out? This is a good student. How do you make out? You ask a few questions. Stretch the breadth of knowledge and the depth of knowledge. Similarly, in a structure, what are the requirements? Any structure, need not be concrete. Yes?
Should respond as per our needs.
Now, what are your needs?
Should uses.
Huh? No. You're following a code, the code understands. What are the requirements of a structure that you need to be aware of while designing? It could be over-designed, it could be under-designed. If it's under-designed, it doesn't qualify, it fails. If you're over-designed, someone has to pay for it. It's uneconomical. So, from the client's point of view, economy is one requirement, but we push it at the end. What's the first requirement? Safety. Structure has to be safe. What do you mean by safe? here you can cover serviceability. No, but we normally, what do you mean by safe? So we separate out safety into 3 S's. 3 S's are, first the structure has to be stable. So stability is the first requirement. Second, the structure has to, because if it's not stable, then you can't even load it. Second is it should be strong. Third is it should be serviceable, or it should be sufficiently stiff so that the serviceability is satisfied. Is it clear? So what is strength? The structure should be strong. There we are talking about the limit states of collapse. The failure here is collapse. So we are stretching it to the limits and saying, yes, there are certain loads, but those loads could be exceeded. But we will say, under the worst conditions, it should not collapse. So, but in practice, those worst could be exceeded. An earthquake could come just in your area and could collapse. That's okay. There's a limit to your ability to design. That's fair enough. So strength has to do with limit states of collapse. Serviceability has to do with service load conditions, where those extreme loads don't happen, where day-to-day loads are encountered. You want no deflections beyond a certain limit there. You don't want cracking beyond the limit there. You don't want vibrations beyond the limit there. Is it clear? That's stability. So I'll end by asking a question. What is stability? Again, generic question. When you say a system, now we'll go to generic. When you say a system is stable, when do you say a system is stable?
System which is not deformed.
Is there any system which will not be? Again, I'm asking a generic question. You guys are stuck with engineering. Political instability, economic instability. You heard these words. Instability of differential equations.
There's a small disturbance, it should come back to its initial position.
So, for example, let's say these are the treasury benches. This is the government, Lok Sabha. These are the opposition. We say we have a stable government when these guys outnumber these guys significantly. They say 2/3 majority. But if you've got a wafer-thin majority and you have horse trading and all that possible, few guys walking across here can bring down the whole government. So a little disturbance. So let's say you have behavior response of a system. You have the input to the system, input, output. A little change in the input variables should, that's called a perturbation to the system, should give you only a corresponding small disturbance in the output variable. Y as a function of x1, x2, x3, x4. If you change x1, x2, x4 by 1% or 2% plus or minus, you'll get only 2, 3, 4% change. Not surprising. We talk of sensitivity analysis when even if you have massive changes, one of these variables just doesn't change, so it's not sensitive to that. But if a little movement here can bring a collapse of the system, loses its stability, then you should worry about that. Buckling is like that. Overturning is like that. Sliding is like that. You understand? That we want to avoid. So system should be stable. Okay, we'll go through all these terms later. So that was too stable. We wanted to make it unstable. Yeah.
What's the difference between strong and stiff?
Fantastic question. What is the difference between strong and stiff? First, the spelling. Though they both begin with S. What more? I'll give you a simple example. You're a practicing engineer. Let's say I want to have a slab, one-way slab. It's 3 meters span. What's the thickness of the slab you will give normally? Normally, based on your experience, some of your experience.
100
mm. Can I do it with 50 mm? Why not? Why not? He's a practicing engineer. Why not 50 mm? In MES they don't allow.
Yes.
But
Deflection criteria.
arey, this is IIT. Here we allow everything.
Prayer stress method.
Huh?
Other methods.
The code says L by D ratios should be satisfied, but I violate them. What happens? What's going to happen? What's going to happen is it loses its stiffness. You know, the moment of inertia is a function of dV cubed by 12. So depth is, if you reduce from 100 to 50, your stiffness reduces 2 raised to 3, 1/8. That's a huge, so you'll get large deflection, you'll get cracking. But still you can live inside that structure. Only you'll have to walk like that. You'll have to do a little dance and rainwater will collect there, right? And people sitting below will not be listening to you in class. They'll be always looking up, wondering whether this roof is going to fall on their heads or not, right? So there's also psychological problem. But let's say you're using it for storage. And let's say there's no danger of corrosion. There's no sea anywhere. And say there's no moisture in the atmosphere. And you want that structure to last only 10 years. Arey bhai, it's possible. So there are no rules here. It all depends on what is a qualifying requirement. But I can put enough steel there to generate the bending moment capacity and the shear capacity to meet the requirements of analysis, but I don't violate. Someone, see, it's left to you to specify the deflection limit. I say there's no limit, I don't give a damn. So your stiffness has to do with load deflection or rotation. So if you make something very deep, a beam deep, it's stiff. And if it doesn't deflect at all, we say it's rigid. Otherwise, it's flexible. Okay, time's up. So I'll end up with this. This is how we do it. 2 quizzes. You'll have assignments, tutorials. You have an end semester exam. It adds up to 100 marks. You've got these dates of the exam. These are all fixed. We'll meet on a Saturday. And these are the reference books. This is a book we follow. It's a book which I wrote 15 years back. When went through 3 editions, this is why we followed a book called Prof. Pillai and I wrote this way back. These were the earlier editions of the same book. Okay, start. Okay, we'll wind up here. So, welcome once again. We meet on Wednesday. It will be a lecture session 2 to 3:30. Thank you.